Okay, so here are the targets 3 and 4 homework. We're finding the discriminant of each quadratic equation, stating the number and type of solutions we have, and then we're going to go ahead and work with the quadratic formula a little bit. And I'll go ahead and write all this up here. The discriminant is b squared minus 4ac, and then the formula for the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac. Don't forget that is our discriminant, all over 2 times a, or 2a. Okay, so you can always write that down on your paper right now, or get it from the notes. Okay, so number 1. To find the discriminant, I first need to identify my a, b, and c values, and I'll do that just from looking at this equation. Let us see this thinner. Okay. So there's where I get my a, there's where I get my b, and there's where I get my c value. My a value is just 1, my b value here is 2, and my c value is 1. So when I do b squared minus 4ac, I'm going to do q squared minus 4 times a times c. So I get 4 minus 4, which is 0. When I get 0 as my answer, that just means I have one real solution. Oops. I don't know why I was doing my work up in the corner like that. I can just do it down normally. Alright. Do the next one. My a value is 8. My b value is negative 4. And my c value is positive 4. So b squared minus 4ac is going to look like this. I took my b value and I squared it, subtracted 4 times a times c. This gives me positive 16 minus 4 times 8 times 4 is actually 128. And that value gives me negative 112. When I get a negative for my discriminant, that just means I have 2 imaginary solutions. Alright, now that we know how to do the discriminant, let's move on to finding the answers for the quadratic formula. Alright. The first one, I'm first going to start by finding my discriminant. It's going to help me out a lot. My a value is 2, my b value is 2, and my c value is 9. So b squared minus 4ac looks like this. 2 squared gives me 4. 4 times 2 times 9 gives me 72. So I have a negative 68, which means I have 2 imaginary solutions. So I'm going to look for that in my answer. And if I don't end up with 2 imaginary solutions, then I probably did something wrong and I need to check my work. So always finding your discriminant first is a good way to kind of start these problems. I'll do a different color here. And x equals the quadratic formula. Negative b, so negative 2 plus or minus the square root of my discriminant. I got negative 68 all over 2 times a. In this case, it's going to be 4. Now, I have to simplify the square root of negative 68. And this is going to be kind of a throwback to Target 1, where we actually did a whole lesson on simplifying square roots. So I'm going to do that math over here to the right, kind of. I have the square root of negative 68. I'm going to do the exact same process we did in the notes. I'm going to start by breaking this up to be negative 1 times 68, or the square root of negative 1 times the square root of 68. The square root of negative 1 gives me I, and then 68, I can actually break that down a little bit. So if I break 68 up, let's see, grab a calculator. 68, I'm just going to divide it by 4 and see what happens. 17. Okay, that worked. 4 times 17. Now, 17 is prime. I'm going to box it. 4 is not. 4 can be broken up into 2 times 2. Now I'm going to box those 2's. So what happened here is I'm leaving my I out front. Then I have the square root of all of this. 2 times 2 times 17. Well, as I have a pair of 2's, I'm going to pull those out. So the answer here is 2I root 17. That's root 68, simplified all the way. So my answer on the left here becomes negative 2 plus or minus 2I root 17 all over 4. And root 17 couldn't be simplified, so I'm just leaving it as root 17. But what can happen here is that because 2, 2, and 4 are all even numbers, I'm going to divide those by 2 and simplify that. Now, I'm never going to touch the number in the square root. That's always going to stay. So if I'm ever simplifying, like I'm about to do, don't ever worry about what's in the square root. That's just going to stay what it is. Dividing all of these by 2, and I get 1, 1, and 2. So my answer is negative 1 plus or minus I root 17 all over 2. All right, number 4. Find the discriminant first. A equals 11, B equals 6, and C equals negative 6. So B squared minus 4AC 36. 4 times 11 times negative 6 is actually, let's see. 4 times 11 times negative 6. 4 times 11 times negative 6. That gives me negative 264. So I'm subtracting a negative 264, which means essentially I am adding 264. And when I add those two together, I get 300. So a positive answer, which means I should have 2 real solutions. All right, let's do the quadratic formula now. X equals negative b, so negative 6, plus or minus the square root of 300, all over 2 times a, and 2 times 11 gives me 22. Now over here off to the side is where I'm going to do my simplifying of root 300. I'm going to break this down into 3 times 100. Now don't forget, you can break that down into anything you'd like. As long as you're doing it correctly, it should all reduce to the same thing. So 3 is prime. Boxing that up. 100 is not. I'm going to break this up into 2 times 50. 2 is prime. 50 is not. I'm going to break this up into 2 times 25. Then you can do 5 times 10, 2 times 25. It doesn't matter. And then 25, I'm breaking up into 5 times 5. And both those are prime. So when I write the simplification of this, I actually have the square root of 3 times 2 times 2 times 5 times 5. So I'm going to circle all the pairs I see and pull out one number from each of those pairs. So I'm pulling out a 2, I'm pulling out a 5, and I'm leaving that lone 3 in there. So this actually simplifies to 10 root 3. So moving back up to the problem I was on, x equals negative 6 plus or minus 10 root 3 all over 22. All right, now if you notice, 6, 10, and 22 can all be divided by 2, so I'm going to do that division. This becomes 3, this becomes 5, and this becomes 11. So my real answer is x equals negative 3 plus or minus 5 root 3 all over 11. Notice that I did not touch this root 3 when I simplified at the end there. So let's check. I was supposed to get 2 real answers, and I did. I got negative 3 plus 5 root 3 over 11, and then I got negative 3 minus 5 root 3 over 11. The 2 solutions comes from that plus or minus. That means I have 2 solutions. And then the fact that I have no I values in my solution means both my answers are real. If I were to have I in my answer, like I did on number 3, that means both those solutions are going to be imaginary. I'll break this up a little bit because it was kind of long. All right, in number 5, oops. In number 5, notice I don't have a b value. I have a p squared minus 21, so my a value is 8. My b value, though, doesn't exist, and then my c value is negative 21. So because I don't have a single x to the first power, or what we call a linear term in this quadratic, I don't have a b value. My b value is just 0. So starting by finding the discriminant here, a is 8, b is 0, and c is negative 21. So when I do this math, b squared minus 4ac, 0 squared minus 4 times 8 times negative 21. 0 squared is just 0. And then when I subtract 4 times 8 times negative 21, I get 672. Which means I'm going to have 2 real solutions. All right. So let's go ahead and do the quadratic formula here. X equals negative b, negative 0 is just 0, plus or minus the square root of 672 all over 2 times a, which is actually just 16. Now off to the right, I'm actually going to do that, root 72, or root 672, sorry, and simplify that. I'm going to break that down into, let's see, can that be divided by 4? Yeah, 4 and 168. Now 4 can be broken up into 2 times 2. And then 168 can be broken down into, let's see, 168 divided by 4, 4 and 42. Four can be broken down into 2 times 2. And then 42 can be broken down into 2 times 21. 21 can be broken down into 3 times 7. And at this point, I'm done. 3 and 7 are both prime, so I'm just going to leave it as that. Now, rewriting this, the square root of 672, 2 times 2 times 2 times 2 times 2 times 3 times 7. I'm going to circle pairs. I have 2 pairs of 2's. So I'm going to pull out a 2 and another 2. So I'm essentially pulling out 2 times 2. And then I'm leaving in here everything else, 2 times 3 times 7. So this is actually 4 root 42. Alright, so going back over here, x equals, I'm just going to say nothing here because negative 0 is just 0. So the plus or minus version of 4 root 42 all over 16. Alright. And then if you notice, I can actually simplify 4 and 16. Dividing both of those by 4, I get 1 and 4. So my answer is plus or minus square root of 42 all over 4. I know that's kind of small. Alright, now I don't have a lot of room for number 6. So what I'm going to do is actually erase some of this up here. Alright, start by finding the discriminant of number 6. My A value is 1, my B value is negative 11, and my C value is negative 12. So B squared minus 4AC when I plug that into the calculator, I get 121 plus 48, which is actually 169, which means I have 2 real solutions. So I'll check that as I go along. My quadratic formula now. X equals negative B. My B is already negative, so I'm making it positive, plus or minus the square root of B squared minus 4AC, which is just 169, all over 2 times A, which is just 2. Now off to the side, I'm going to do the square root of 169. Let's simplify that. 13 actually goes into it evenly. 13 times 13 is 169, which means 169 is actually a perfect square. 13 is prime, so this actually just ends up being the square root of 13 times 13. And because that's a pair, I'm just going to pull it out front, and I'm left with the square root of 1 technically, but that's just 1. So my answer is 13. So going back up here, 11 plus or minus square root of 169 is actually just 13 all over 2. And if you're ever left with something like this, I have no more square roots, I have no imaginary numbers, I can actually do this math. 11 plus 13 over 2. That's actually just 24 over 2, which is 12. So here's one of my answers. And then 11 minus 13 over 2, that's just negative 2 over 2, which is negative 1. There's my other answer. So I didn't mean to box up 13 right here. But 12 is one of my answers, and negative 1 is another answer. So I got 2 real solutions, which is exactly what my discriminant predicted. Alright, final ones down here. This one, my A value is 4, my B value is 4, and my C value is 5. So when I do B squared minus 4AC, looks like this. 16 minus 80 gives me negative 64, which means I'm going to have 2 imaginary solutions. Alright. Let's go to my quadratic formula now. X equals negative B plus or minus the square root of negative 64 all over 2a, which is 8. I'm going to simplify the square root of negative 64 off over here. This becomes the square root of negative 1, and then the square root of 64. Square root of negative 1 is I, and then 64. If you notice this right away, it's actually a perfect square, 8 times 8. If you don't, though, I'm going to help you out here. So let's say that square root of 64 is, we'll say 4 times 16. Well, 4 can be broken up into 2 times 2, and 16 is 2 times 8, or you could say 4 times 4. 8 is 2 times 4, and then 4 is 2 times 2. So I'm going to box up all these 2's. and this is actually I square root 2 times 2 times 2 times 2 times 2 times 2. So when I circle all of the pairs that I have, 1, 2, 3, that means I'm pulling out not 1, not 2, but 3 2's. So this becomes I times 2 times 2 times 2, and I have nothing left on the inside. So actually this is I times 8. We'll rewrite that as 8I. Alright, so now that I have that simplified, I'm going to bring it back up to the top. Negative 4 plus or minus, we figured that was 8I all over 8. And if you notice, all 3 of these can be divided by 2. They can actually be divided by 4, actually, so I'm going to do that. Divide all these by 4, and I get 1, 2, and 2. So my answer is negative 1 plus or minus 2I all over 2. And finally, I'm gonna, whoops. Let's move that around. Alright, that's what I meant to do. What I actually meant to do was kind of move this stuff. Oops, not that. Just gonna kind of shrink this out a bit. Alright, sorry. Okay, now I have more room. For number 8. So, start by doing my discriminant. My A value is 3, my B value is 0, and my C value is 6. So if you notice again, we're missing that linear term in the middle with just the x, which means our B value is 0. Whenever you're missing that term, that A, B, or C value is always going to be 0. So when I do A squared, or B squared minus 4AC, I get 0 squared minus 4 times 3 times 6. So 4 times 3 times 6 gives me negative 72 is my answer. So I have 2 imaginary solutions. Alright, and let's see, let's start by doing my quadratic formula. X equals negative b, which is just 0, plus or minus the square root of negative 72 all over 2 times a, which is actually just 6. I'm going to do the square root of negative 72 down here. I don't know what this is. Okay, what? I don't know what just happened. Anyway. It's going to be broken down into the square root of negative 1 times the square root of 72. And then we all know that the square root of negative 1 is just I. 72 can be broken down into 12 times 6. 6 is 3 and 2, and those are both primes, so I'm going to box those and just work on 12. So 12 is also 6 is 2, and then 6 is again 3 times 2. So the square root of negative 72 reduces down to this. I still have that I out front. I have the square root of 3 times 2 times 2 times 3 times 2. So I'm going to circle some pairs. Circle my 3 pair like this. Didn't put them in the right order, but that's okay. Which means I'm going to be taking out a 3 and a 2. So I have 3 times 2 times I, leaving that loner 2 in the inside there. This becomes 6I root 2. So scrolling back up, I'm going to put that back into my formula. Plus or minus 6I root 2 all over 6. Now I didn't add my 0 out front just because it doesn't matter. I can leave it out. It's just 0. And I can actually reduce this just a little bit. Divide both those by 6. and this actually reduces pretty nice. Plus or minus I root 2. And there's your homework for targets 3 and 4.